So today we're going to deal with an area in chemistry. It's very important. It's called stoichiometry. Okay? Stoichiometry is the area that deals with the quantitative relationships among reactants and products in a chemical reaction. So a real-world example of this is when chemists add chemicals together, say they want to produce something. It's just not a guessing game of, well, if I want to make 10 grams of product, do I just throw an X amount, or how much do I put in of the starting material? So an example of this would be if our end product, say we want to create a chair with 4 legs, right? So we have a chair, so here's our product. We know our chair has 4 legs, okay? So to create this chair, we know we had to start it with a back plus a seat plus 4 legs, and that'll give us 1 chair. If we start it with 2 backs, a seat, and 5 legs, we would have 1 complete chair with a leftover leg and a leftover back. And we don't always want that. We don't always want to have extra stuff. So chemistry is a lot the same. We don't have to guess, oh, how many, a chair with 4 legs, everybody knows you need 4 legs. You don't need 5 legs to make a chair with 4 legs. And the same can be said with chemistry. So let's take a look at a combustion reaction. So in a combustion reaction, like a propane grill that probably a lot of your parents have out in the back, you have propane and oxygen react together to yield carbon dioxide plus water. So if we go through and balance this equation, we'll have a 5 in front of the oxygen, a 3 in front of the carbon dioxide, and a 4 in front of the water. Now these numbers that we use at the front, the coefficients for balancing, they don't only tell us how many molecules and how many atoms of each thing we have, they are also mole ratios. So mole ratios. They tell us that if I have 1 mole of propane, because remember there's an imaginary 1 here, 1 mole of propane plus 5 moles of oxygen will yield 3 moles of carbon dioxide plus 4 moles of water. So a question could be, how many moles of water, and this is often what stoichiometry is used for, how many moles of water that's a W, are produced when 5 moles of propane are burnt. So, how much water is produced when we burn 5 moles of propane? Well, we have a mole ratio here. We know that for every 1 mole of propane, 4 moles of water are made. So we could set up ratios here. So we could say, I'm burning 5 moles of propane. I'll just use a P for propane. And I know a mole ratio, I know that for every 1 mole of propane, I'm going to get 4 moles of water. So if I set this up for H2O, for every 1 mole of propane, my moles of propane will cancel. I have 4 times 5, and it tells me that I get 20 moles of water produced every time 1 mole of propane or 5 moles of propane is burnt. The other place where something like this is useful is, say you're a chemical manufacturing company and you make ammonia. So ammonia, NH3, is often used in fertilizer and in home cleaning supplies. So as a company, you don't want to waste excess reagents. So when you make ammonia, you want to make sure you make the right amount. You want to buy the right amount of chemicals to make the amount of ammonia you want. So the reaction to create ammonia is when you have nitrogen gas plus hydrogen gas yields ammonia gas. Okay. So let's say we've opened Base Chemical Company, and for our first run, we want to make our customers have asked for, they want 170 grams of ammonia produced. So us as a company, we need to make 170 grams of ammonia. I don't want to make more, I don't want to make less, I want to make sure I use the right amount of hydrogen and nitrogen. Oh, and first, you have to balance equations before you can do stoichiometry. If your equation is not balanced, you will not be able to come up with the right mole ratios. So let's see here. So I want to produce 170 grams of ammonia. How many grams of nitrogen and how many grams of hydrogen do I need to produce that? So then we can buy the right amount and so we don't have waste. So let's go through. First, your first step is going to be to convert 170 grams of ammonia to moles. Now we know that nitrogen has a molar mass of 14. Hydrogen has a molar mass of 1, and I have 3 of them, so 3 times 1 gives me a molar mass of 17 grams per mole. If I have 170 grams, and I want to know how many moles that is, I have 170, 1 mole, 17 grams, my grams will cancel, and it will tell me I have 10 moles. So we want to produce 10 moles of ammonia gas. So what do I need to start with? So let's look at our mole ratios here. I know that for every 1 mole of nitrogen, I will produce 2 moles of ammonia gas. So let's set this up in mole ratios. I know I want to produce 10 moles of nitrogen gas, or ammonia gas, sorry. So 10 moles of ammonia gas, let's set up my ratio, the straight line, maybe one of these times. 1 mole of nitrogen gas over 2 moles of ammonia gas. Do the math here, moles of ammonia cancel, and it tells me I need to start with 5 moles of nitrogen. And how many moles of hydrogen do I need to have? Well, let's see. So again, I want to produce 10 moles of nitrogen or ammonia gas. So I have 10 moles of ammonia. My mole ratio is I know that I need 3 moles of hydrogen gas to produce 2 moles of ammonia. So let's put those ratios in. 3 moles of hydrogen per every 2 moles of ammonia. My ammonia will cancel. I'll have 10 times 2/3, or 3/2, sorry, which would be 15 moles of hydrogen. Okay, so to produce 170 grams of ammonia gas that can be used in fertilizer or anything else, I need to start with 5 moles of nitrogen and 15 moles of hydrogen. So once I have the moles, I can go backwards and find the number of grams. So let's do that. Let's find out how many grams of each we need. So 5 moles of nitrogen. I know that nitrogen is N2. So I have times 28 grams per 1 mole. Our moles will cancel, and it tells me I need to start with 140 grams of nitrogen. And how much hydrogen do I need to start with? Well, if I have 15 moles of hydrogen, I know that hydrogen, H2, has a molar mass of 2 grams per mole. My moles cancel, and I have 30 grams of hydrogen. So, in order to produce 170 grams of ammonia, we need to start with 140 grams of nitrogen and 30 grams of hydrogen. When we add those two together, we will get our quota of 170 grams of ammonia. So this is what stoichiometry is. Stoichiometry is using balanced chemical equations and mole ratios to find out how much of something is produced, how much of something is needed to produce a certain amount of something. And there's 4 types of stoichiometric equations that you can do. So this is used when you go from moles to moles. So how many moles of ammonia gas is produced when you have 10 moles of nitrogen? You can do that. You can do mole to mass. If I start with, say back in our propane example, if I start with, say, 15 moles of propane, and I want to know how much water is produced, I can find that. So I have my balanced chemical equation. I have C3H8 plus 5O2 goes to 3CO2. I don't know why my lines are doing that. Sorry about that. Plus 4H2O. So let's say I start with 5 moles of propane. So 5 moles of propane. And I want to know how much water is produced, the mass. I want to know what's the mass of water produced when I have 5 moles of propane. So I can do that. I have a mole ratio. I know 1 mole propane gives 4 moles of water. So if I set that ratio up, I have, let's just use this here. So starting with 5 moles of propane, my mole ratio is 4 moles of H2O plus 1 mole of propane. My propane cancels, and it will tell me when I have burned 5 moles of propane, I am left with 20 moles of water. If I have 20 moles of water, I can find out how many grams that is, correct? So I know that 20 moles of water, I know that 1 mole of water weighs 18 grams. So all I do, it's easy as taking as 20 times 18, and that gives me 360 grams of water. So stoichiometry is very useful for calculations like this. And if you can go from mole to mole and mole to mass, you can also go from mass to mole. And you can go from mass to mass. So tomorrow what we'll do is we'll look at some practice problems using balanced chemical equations, mole ratios, to see if I start with, to see if starting materials, any materials do I need. If I want to say you wanted to get 300 grams of water, how many moles of propane would I need to burn? So we'll take a look at that tomorrow. Hopefully this video isn't too bad and you guys can learn something from it. See you guys in class.